Hi guys, so today let's do question 7 of the June 2026 mathematics question paper. So 7.1 says determine f prime x from first principle if it is given that f of x is equals to x squared plus 2x. So what I want us to do first, to write our, okay, let's go and write 7.1 and we write our function which is given, which is f prime x, and not f prime x, but f of x equals to x squared plus 2x, right? So they say determine f prime x, or the derivative of f, using first principle. So you know, for you to be able to do that, you have to know the formula for first principle. So the formula for first principle, it says f prime x, it's equals to limit when h approaches 0, f open brackets of, or f of x plus h, minus f of x, then all this is divided by h. So what does this formula mean? So if you can see, the formula says limit when h approaches 0. So it should be in a way that when you're solving these, your h should be able to approach 0. It means you have to make sure that you get rid of the h in the denominator, because remember, if you say your h approaches 0 when you still have h in the denominator, when you divide, you cannot divide an equation, or you cannot divide a fraction by 0. That will give you an undefined answer. So you have to make sure that you get rid of the h in the denominator. So first thing that you have to do, you have to find your f of x plus h and your f at x. So you know your f of x, it's that function which is given there. So let's go and find our f of x plus h. So f of x plus h. So what are you going to do now to find this? You just go to your original equation which is given, or your original function. So everywhere where there is x, you are going to replace that x with x plus h, right? So let's go to the original function. So we have x squared there, so it means you are going to replace x squared, x there, with x plus h, and then we square it since the x there is squared, and then we have plus 2 x. So in place of x, we are going to replace it with x plus h, right guys? That was simple. And then now we can go and expand our brackets. So as you can see, we have x plus h all squared. So this is the same as x plus, open brackets, x plus h, close brackets, open brackets, x plus h, plus 2 open brackets x plus h, right? And then now just allow me to change my color. So now we're going to expand our brackets now. So this x will multiply with the x on the second bracket, and this x will multiply with the h on the second bracket, and this h will multiply with the x, and this h will multiply with that h there, right? And here this 2 will multiply with that x, and this 2 will multiply with that h. So this is how we expand our bracket. So we have x times x, which is going to give us x squared, and we have x times h, which is going to give us plus xh, and we have h plus x, which is going to give us x plus h, and we have h times h, which is going to give us plus h squared, right guys? And here we have 2 times x, which is going to give us plus 2x, and we have 2 times h, which is going to give us plus 2h, right? So let's go and see, or let's go and add like terms, and subtract any like terms that you have from that equation. So you see we have x squared there, we only have one x squared, so we'll write it as it is. And then we have xh plus xh, so those are like terms. So xh plus xh, it will give us 2xh, and then we have h squared there plus 2x plus 2h, right? So this is f of x plus h. So now since you have f plus, or f of x plus h, you can now go and substitute everything in your formula for first principle and then find your derivative. So let's just go and rewrite our formula. It says f prime x is equals to limit when h approaches 0, f of x plus h minus f of x, and all these divided by h. So we're just going to put everything that we have there. So it's limit when h approaches 0. We know that f of x plus h is this. So it's going to be x squared plus 2xh plus h squared plus 2x plus 2h, right? And then we're going to say negative. And then what I want you guys to do every time, just come and put the bracket there so that you can distribute this negative properly there. So you're going to put f of x there, which is x squared plus 2x. Then you're going to have x squared plus 2x there. And then you close your bracket. Then all this is divided by h, as how the formula is there. So let's just go and expand our brackets there. F prime x when limit when h approaches 0. I'll just rewrite that x squared plus 2xh plus h squared plus 2x plus 2h. And then now we have negative times x, which is going to give us negative x squared. And we have that negative times 2x, which is going to give us negative 2x. So this is the reason why I say you should put brackets, because one might just come in and put the equation or the original function as minus x squared plus 2x, and this is not how it should be, guys. So don't make that mistake. Always put the brackets there. So let me just indicate with arrows there, red arrows, that this negative will multiply with that and this negative will multiply with that. So let's continue. And then all this is divided by h, right? Then let's just go and add and subtract like terms from the numerator, guys. So if you can see, we have x squared here minus x squared, so that's 0. We have 2x minus 2x, which is 0. So you'll be left with 2xh plus h squared uh, plus 2h, which is that one, on the numerator, and then all these will be divided by h. So if you can see, our aim is to get rid of h in the denominator. So how can we do that? So we're going to have f prime x when equals to limit when h approaches 0. But if you can see on the numerator, we have h on the first term, second term, and the last term. So meaning h is our common factor there. So we can take out h as a common factor. So therefore, when we take h as a common factor, we're just going to write h there, and we open the brackets. So that 2xh we will write it as 2x, because h times x, h times 2x, it will give us 2xh, and then that h squared will write it as h, because h times h, it will give us h squared, and that 2h will write it as 2, because h times 2, it will give us what? H squared, h 2h, sorry. And then all these will be divided by h. Now you can see that we can be able to get rid of h in the denominator, because that h there will cancel with that h there in the denominator. Therefore, you are now left with f prime x limit when h approaches 0. You have 2x plus h plus 2. Now you can see that your h can approach 0 now. So therefore, your final answer will be f at x, it's equals to, you remove the limit when you write your final answer, since your h has approached 0 now. So your final answer will be f prime x equals to 2x plus 2. So this is your final answer to 7.1. Let's continue. Let's go and do 7.2 now, guys. So let's see, can I just erase everything here? Let's see if I can do that fast. So guys, you can join my classes for mathematics. I offer extra lesson for both grade 12 and grade 11 and grade 10. You can just check my number for WhatsApp on the description. And the class, they are affordable. I also offer some classes for free to those students who cannot afford to pay. So let's go and do 7.2 now. 7.2.1. So they say determine the derivative of f if f at x is equals to x squared minus x minus 6. So our function which is given is f of x is equals to x squared minus x minus 6. They say determine the derivative of this if determine the derivative of this. So this is a very simple question because you can also see the marks there is just 2 marks. So what you have to know about this, you just have to know the rules of differentiation. Like how do you differentiate an x? What do you do when you have a common number? How do you, not common but a constant number, how do you differentiate that thing? You know, guys, so for us to differentiate this, you know that differentiation works in a way that when you have x to the power n, the derivative of x to the power n is equals to, you just take this n in front, and after taking n in front, from n you're going to minus 1. So therefore you're going to take n in front and you have x there, and then you're going to say n minus 1, right guys? So since there you have x squared, it means what you're going to do, firstly you're going to say f to the power f prime x is equals to, you're going to take 2 in front, and then you have x, and then in the exponent you're going to say 2 minus 1, and then minus. Remember here you have x, so x, since it's x, it's same as x to the power 1. So therefore it means you're going to take that 1 in front and you have your x there, and then in the exponent you're going to have 1 minus 1, right? And then the derivative of a constant, it's always 0. So derivative of a constant, it's always 0. So it means the derivative of 6, since it's a constant, is going to be 0. And then therefore now you're going to have a final answer of f prime x is equals to 2x. There on the exponents, 2 minus 1, it will give you 1. And then here you're going to have minus 1, because x to the power 1 minus 1 is going to give you x to the power 0, and any number to the power 0, guys, it's 1. So therefore you're going to have 1 times 1, which is going to give you 1. So this is how you derivate something like this. So now let's go and do question 7.2.1. So it looks tricky, but it's not that tricky. It's a very simple question. Same here, you just have to understand some basic rules of differentiation. So let's go and do that. 7.2.2. So they say determine d over dx of so that's, I believe, I cannot see it properly, but I think it's cubic root of 24, that's 27, sorry, 27x to the power 4, and then plus 2 over x to the power 3, I believe so. Then you just have to determine the derivative of this. So how do you do something like this? So what you have to know also or understand in differentiation, guys, you cannot derivate when x it's inside a square root. You cannot derivate when x it's in the denominator. So therefore you have to make sure that you remove square roots before you derivate. You have to make sure that your x is not in the denominator, right guys? So let's go and remove our x, or let's go and remove square root from our equation, and also let's go and remove this x from the denominator in our equation. So how do we do that? So what are you going to do? You're just going to come and say your equal sign. So you know that a square root, if it's just this normal square root of let's say square root of x, so square root of x, guys, is the same as x to the power 1 over 2, right? So therefore the square root of the cubic root of x, it will be the same as x to the power 1 over 3, right? So therefore what we are going to do here, we're just going to have since we have something like that, so this, remember, what is inside the cubic root there is 27x to the power 4. So therefore we're going to have brackets 27, open brackets, 27x to the power 4, and then close brackets, and you have our 1 over 3. The reason why I put this thing inside the brackets, it's for you guys to know and understand that this cubic root is not only being shared by x, but by everything which is inside the cubic root, right guys? So therefore we're going to have plus, and then here you guys should know that if you have something like 1 over x, this is the same as x to the power minus 1. So therefore, since there you have 2 over x divided by as over x to the power 3, this is the same as 2 times x to the power minus 3, right guys? So this is what we are going to do there. So you're just going to say 2 times x to the power minus 3. So therefore, let's just simplify this further. So if you can go on your calculator and just say 27 to the power 1 over 3, it will give you, it will give you 3. So what you can do, 27 to the power 1 over 3, it will give you 3, and then therefore you'll have 4 times 1 over 3, which is going to give you 4 over 3, and then plus 2x to the power minus 3. Therefore, now when it's like this, you can see that you don't have any x which is inside the square root, and you don't have any x in the denominator. Therefore, you can start derivating. So you just have to come and write your d over dx is equals to, now remember, how do you derivate? You're going to take the number in the exponent in front, and then from the exponent you minus 1. So therefore you're going to come and say 4 over 3, which is your exponents, times 3x to the power 4 over 3 minus 1, then plus negative 3 times 2x to the power minus 3 minus 1 on the exponent, right guys? Then there you have d over dx, just to simplify this. So 4 over 3 times 3, obviously 3 will cancel with 3 there, and then you'll be left with 4x, and then 4 over 3 minus 1, can just do that with our calculator, and it will give us 1 over 3. And then obviously negative 3 times 2, it will give you negative 6x, and then negative 3 minus 1, it will give you minus 4 there. So this is your final answer, but you can, if you want to write it in a proper way, you can also write it like this. Since you have x to the power 1 over 3, you know that 1 over 3, x to the power 1 over 3, you can also write it as a cubic root of x minus 6x. Since there you have, okay, that one you can write it as minus 6 over x to the power 4, since x, the exponent there on x, it's negative 4. So thank you very much guys. I hope you enjoyed the lesson and you learned something. So don't forget to like, subscribe and share. Thank you very much.